Okay, so in our reference material, you can see your different constants here. So I'm just going to kind of point them out to you so that you know where they are. First of all, you also have your conversion between all of your different pressures. Remember, millimeter mercury is torr, but the R, this is your ideal gas constant. So I want to kind of point out to you, they all have this mole K, mole K, mole K. All right, so what that tells you is temperature and moles aren't going to really change. So as long as you are in Kelvin and moles, you're fine with those two. Then you also notice we have liters, liters, liters. So that means that volume is also never going to change. What you do see, though, is you have ATM, kPa, millimeter mercury. So these are just the units for these different values. So this right here is why pressure is going to be so important to pay attention to, because it's going to tell you which one of these numbers you're going to use for R, which is our gas constant. So we are going to pay attention to that. So let's go ahead and line this up with what we have on our lab, and then we'll come back to this and see what we have. So you saw that we had, don't worry about the grams, right? So moles, we're going to figure out moles. So don't worry too much about that. All right, but we saw that we have liters, we have Kelvin, and then we measured it in millimeter mercury. So once again, these we don't really care about because they're always going to be the same, but this part does matter. So we're going to look at our little reference chart. So we want to find the one that has millimeter mercury. So not this one, not this one, this one. So we have 62.4 because we're measured in liters. We had Kelvin. We're gonna solve for moles. And we're going to use this in order to do that, but we have millimeter mercury for our pressure. So you don't do any kind of math with this, you just pay attention to it, and that's how you're going to decide which gas constant you're going to use. So we're going to use 62.4. That's what we're going to add to our little chart right here. So determine which R value to use, 62.4, and it's going to be liters times that millimeter mercury all over mole times K, right? And that takes care of all of our different units that we have. Okay, so now we have our entire data table filled out. So the first question that we're going to be approaching is we are going to be solving for N, or our moles. Now that we know which R to use, we're going to just go ahead and use that ideal gas law in order to figure out the moles, okay? All right, so we have our ideal gas law already laid out here. So remember, this is coming from PV equals nRT. All that we did was we moved this stuff underneath. Okay, so we divided it underneath. So we're going to grab our pressure, which was the 743 millimeter mercury, right? So we got our pressure of the butane. That's what we're talking about right now. So only focusing on butane. So we have 743.0. That's our pressure. We're going to multiply this one times the volume, which was right here, so 0.091 liters, okay, so that's P times V. We're going to divide all that by R, which was the 62.4, times temperature in Kelvin, so 292.8. Now, I know I put a lot of parentheses in here, so let me show you when you go to type this in how easy it will be, okay? So we're going to go ahead and clear that out. All right, so we're going to start with our top line. We're going to say 743.0. We're going to multiply it by 0.091. That's our whole top line. So I recommend you push enter at that point, right? So everything up top got multiplied. Now we're going to go ahead and divide it by, I'm going to open up parentheses to fill up the whole bottom. We're going to have 62.4, and then we're going to go over here, times 292.8. The other way that you could have done this if you didn't want to use parentheses is divide, divide.